Okay, in 3.2, it's more of the same from 3.1. We're talking about the derivative being this limit as h approaches 0 of this thing that we've been working with. And the process of finding a derivative is differentiation. Okay, this is one half of the whole course, really, differentiation. You have some different notation. It might be d dx, that could mean derivative, or f prime of x, or you might even see y prime. That's all notation for the derivative. I usually use f prime of x, but in the middle of things, sometimes I use this. So you'll see when we get going to do that. Not today. I throw this out there, but we're really not doing derivatives that way yet. Okay. And I did put some things in about when does a function not have a derivative. So you'll have these in your notes if you need it. At a corner, at a cusp, when it comes in, the blue lines are the things that were the functions. A vertical tangent, and a discontinuity, because things have to be continuous to have a derivative. So those are some pictures that you would have in your notes. And then it talks about if it's differentiable, if you can take the derivative of it, it implies that it's continuous. You have to be continuous to take a derivative. Okay? So that was just some things to pull out. And this is in there, but I decided not to give you any problems using this. I had one in there. You'll see it in the notes if you want to look at it, but I didn't give you one for homework, and I won't hold you responsible for one. So if I were you, right here, I'd be there. Okay, let's look at the problems and see what we need to do. Okay. So it says using the definition. When it says that, we're doing the same thing we've been doing. Calculate the derivative of the function, then find the values of the function as specified. You guys that know calculus, there is no one standing over your shoulder that says you have to do it by the definition. You'll have to do some on the test, but could you? Who can tell me what the derivative of that is right there? Negative 2x. Negative 2x, and so then f prime. So this is f prime of x, and then f prime at negative 3 would be 6 and 0 and negative 18. And that was that quick that they did that, because they know the derivative rules. And very soon, like next week, we'll be doing it that way. You guys, but what I'm saying is, you're just plugging in answers. Oh, the hard way. I mean, and then he came up with the rules. You know, you can thank Isaac Newton for most of this. He was about your age, maybe a little younger when he did it. He didn't have Xbox or anything to play with, so he was doing that. But, you know, just that quick, you can get those answers. But if we're doing it by the definition, which some of us, that's all we know to do right now, we have to do that still, the limit as h approaches 0. And what do we got? 2 minus x plus h minus, what's f of x? See, we don't have a y value. We're just finding generally. So what are we going to subtract here? The original. The original. So do that and see how you go with that one. See how that gets started for you. Well, for right now, we got to clean this up a little bit. So we have 2 minus x squared plus 2xh plus h squared minus 2 plus x squared. And then we're going to change all these signs in here. Let me stop my little... All right. So, where were we? Something cancel out here? That and the 2's, and we're left with the h's, and we can factor out h times negative 2x minus h over h. Limit as h goes to 0. Bam, bam. So as h goes to 0, what do we get? Negative 2x. So we got the same derivative that they shouted out in a matter of seconds, which is what you'll be doing soon. And then once you have that negative 2x, then you're plugging in these x values into negative 2x and getting these values. Okay? All right. Same way here. 3 over t to the 4th. You know how to do it. Now, if you were doing it with the rule, what would be the thing you'd want to remember? Yeah, 3t to the negative 4. But, okay. And everybody else is going, what's the rule? What's the rule? I want to know the rule. So I don't know that we need to work this one here. The notes are all out there for you. Let's do this. Let's do this. Oh, there's that one. Find the mistakes. Where's Waldo? Okay, find him in this. There's certainly room for one of those here. Oh, hurts my head to think about it. There is a lot of stuff. 3t to the 4th minus 3. There we go. You had a lot of stuff. This is algebra. It's just doing the same thing we've been doing. But this was where I made that to the 4th, because you had a lot of stuff to do. And I very well could have left out or changed an h or whatever. You can check that. The limit as h approaches 0 of 3 over this, because it was t plus h to the 4th, minus the original, which was 3 over t to the 4th. Then you had that common denominator stuff, and I just wasn't writing all of this each time. I just drew little arrows and said that's where that should go. That's what you're doing. Common denominators. You come down. Oh, you're going to be just saying bad words about me as you do this problem.
Yeah, I remember doing this and we had to work it all out and then it's sort of...
Okay. Yeah, hang on. I'm just trying to see if there's any of these that are really different. And then I want to do one more thing. Yeah, this marked out. This problem's marked out. Hold on. In the notes, if you'll look at the notes online, number 4 is omit. So if you have the problem set, omit 4 and omit 5, because they won't be in your homework. And then, no. 4 and 5. The alternative, yeah. And then number 6 and 7 are asking you about graphs. 8, shall we look at 8, because you might want to see that one before you approach it. Determine if the following piecewise function is differentiable at the origin. Differentiable at the origin. Okay, so all we're doing is, and it tells you over here, f of 0 plus h minus f of 0. You're saying, here's the function, 2x minus 1. So 2 times 0 plus h minus 1 minus, where did this negative 1 come from? What's the value when x is 0? Negative 1. So when x is 0, your f of x is negative 1. So that's why that's getting subtracted. So you've got 2h minus 1 plus 1 over h. Okay, so that's 2h over h. Do we just get 2? As h goes, well, those cancel out and you're just left with 2. Does that make sense? Or no? That goes, that goes. That goes, that goes. And you take the h approaches 0 of a constant, you're going to get the constant. As long as you get a value here, then this, if they're different, if these pieces are different, can it have the derivative? If you're coming in at different places? So if you get different values here, is it differentiable at 0? No. Okay, so that's what you would do for that one. And 10 is having you look at this. It says, at what points does this thing appear to be differentiable? Well, where's the only point that it's not differentiable? At x equals 0. So it gives you some choices, and it says, where does it appear to be differentiable? And this choice says from -1 to 0, and then from 0 to 2, with 0 not being included. So that does make sense there. At what domain points does it appear to be continuous but not differentiable? At 0, because it's continuous there. It's just not differentiable. At what points does it appear to be neither continuous nor differentiable? There aren't any. So it's just having you look at that and examine that. Okay? So, don't pack up yet.